Kotlin provides floating point types, and we have float and double to represent decimal numbers. So a floating point type differ by their decimal place, that is how many decimal digits they can store. So a float can store 6 to 7 decimal digits and double can store 15 to 16. So as far as their size is concerned, float takes around 32 bits and double takes around 64 bits. With that being said, now we will see how we can create and initialize double and floating point variables. We can initialize double and float variables with numbers having a fractional part. So the fractional part is separated from integer part by a period. Okay, now let's see all of this in action. So what we're going to do is we are going to create a variable named pi, and we're going to assign it a value. So I'm going to type val pi and I'm going to assign it 3.14. So as we can see, we have a period, and that period is basically the separation between the integer and the fractional parts. I hope that makes sense. One thing to note is that for variables initialized with fractional numbers, just like this one, the compiler infers the double type. So what do I mean by this? I'm going to create another variable. So I'm going to type val and call it 1 double, and we're going to assign it to 1.0, right? So this will be treated as a double because for variables initialized with fractional numbers, the compiler infers the double type. So now the question is how we can specify the type of the variable to float. So for that, we have to explicitly specify the float type for a value, and we can do that by adding suffix f at the end. So what I mean by that is I'm going to create a variable. So we're going to name it val, and I'm going to call it float, and I'm going to set it to 2.7. So just some random number. So initially the type of this variable will be double. So to set the type explicitly to float, we have to specify a suffix at the end, and I'm going to type f. So by adding the suffix, the variable will be of type float. So it can be a small f or a capital one. It doesn't make any difference. So it can be in lowercase as well as in uppercase. So that's how we define a float variable. One important thing to note is that we saw that a variable with a type float will have 6 to 7 decimal digits. So now the question is, what will happen if we declare a variable with more than 6 to 7 decimal digits in their fractional part? So to demonstrate that, I'm going to declare another variable, and I'm going to type val, and I'm going to call it another float. And I'm going to set its value to 2.123456789, and to specify it as float, I'm going to append the suffix f at the end. So now I'm gonna go ahead and run the program, and what we're gonna do is we're gonna print the value of another float. So I'm gonna go ahead and run the program, and we'll see the output. So our program is up and running, and we can see the output in the output window. So we can see that we have declared a variable with more than 7 digits in the fractional part, and once we print that on the output window, we can see that we have lost some digits. So our number is rounded off. So that is another important thing to keep in mind. So if the value after decimal is really important, then you should try using the double, because it can contain 15 to 16 digits after the decimal point. One more thing is we can use underscores to make number constants more readable. So what do I mean by that is if we type val 1 million, and I'm going to assign it to 1 million. So to make it more readable, I'm going to type underscore 1 here and 1 here. So this will help our variable to become more readable. As another example, I'm going to declare a variable called credit card number, and I'm going to assign it 1 2 3 4 5 6 7 8 9 0 1 2, some random number, and I'm going to type underscores to make this one more readable, and that will be a long. So if we print the number on the console or on the output window, the underscores will be ignored. So I'm going to try print ln, and I'm going to pass in the credit card number. So I'm going to go ahead and run the program to see the output. So our program is up and running, and we can see that the underscores are removed at runtime. Alright, so that's it for this video, and in this video we saw that how we can define and declare the floating point numbers and how we can improve the readability of our numbers by using underscores. And in the next video we'll explore some more concepts, so see you on the next one.